Hello everybody and welcome to the channel. Today we're going to be doing a fun one. Let's take a look at valid Sudoku. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 through 9 without repetition. Each column must contain the digits 1 through 9 without repetition. And each of the 9 subboxes, or each block of the grid, must also contain the digits 1 through 9 without repetition. As a following note, the Sudoku board is partially filled. It is not a completed Sudoku board. It could be valid, but is not necessarily solvable. And only the filled cells need to be valid according to the mentioned rules. So let's take a look at the input and the output for one example here. So you can see we've got a vector of vectors, and we are looking at strings where we have the string version of the number 5, 3, blah, 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 and empty spaces are filled with a period. In this case, it is currently valid. The output is true. If we were to say have like a 5 here in this block, then it would be false, not because of the rows, not because of the columns, but because this block now contains 2 5s. So how are we going to solve this in Clojure? Let's head on over to the Blackboard. So how are we going to go about solving the Sudoku problem? Well, we know that we have to take care of 3 different cases. We need to see that all the rows are valid, we need to see that all the columns are valid, and we need to see that all of the blocks are valid. The data structure that we have looks like an array with arrays inside, or a vector with vectors inside. And they're already organized in rows. So the first thing that we're going to solve is the rows, and that's going to be relatively simple. We're just going to say for each row, is row valid? Move on to next row. Are all rows valid? Then our rows are valid. The next thing that we do is we need to check the columns, and the columns is going to be very similar to the rows. So we would say, let's make a vector out of this guy here. 1, 4, 7. Let's make a vector out of this guy, 2, 5, 8. Let's make a vector out of this guy, 3, 6, 9. And pass these into the same validator. Because once you're looking at the columns, 1, 4, 7, do we have any duplicates? No. 2, 5, 6, do we have any duplicates? No. It's the same exact check once we have organized the numbers into the right form. Finally, we would look at the blocks, and the blocks is going to have to be a little bit different because here we're going to have to be going and taking 0, 0, and then 0, 1, and then the 1, 0, and 1, 1. And we're going to have to pull these guys out. And what we're going to try to do is we're going to try to take these 4 values and put them into a new vector like so. And once we've got it into this structure, we can set it to the same validator. We go through each row. How do we determine if it's valid? The first one, what we want to do is we want to filter out all of the invalid characters. So we don't want to consider empty spaces. So we would be left with 1, 3, 4. And then the way to check to see if we've got any duplicates is we'll do something along the lines of, putting it into a set. And once we have a set of something and a vector of something, then we could check the count of each of these guys. And if their count is the same, then we know we don't have any duplicates because the set here is going to ensure that any duplicates are removed. There may be a more elegant way to solve that using the Clojure standard library, but I think that's enough for now. Let's get to coding. Okay, so let's move on to the solution. In front of me, you can see that I've already put in a little bit of effort to set this up, mainly because you have different boards in different cases that you're going to want to check, or which I am going to want to check as we are developing the solution for this together. So you can see we've got our valid Sudoku main function here, and then followed with a valid board, an invalid board with the rows, an invalid board with the columns, and an invalid board with the blocks. And this is just going to help us as we are working through our solution. So looking at valid Sudoku, this is going to be very high level, top level function. All we are going to want to check here are whether or not our rows are valid, our columns are valid, and our blocks are valid. So we would have an and statement, and we would say, and we have valid rows and valid calls and valid blocks. Of course, these functions don't exist yet, so let's get these guys defined and into the REPL as well. Valid rows, and this will be taking our board. We're going to do this underneath. Valid calls and valid blocks. And these guys are also returning Booleans, so we're going to throw a question mark at the end of them. And these guys are going to take the board as the argument. Good. And for each one of these, we are going to be checking each group or each part of the board to see if it is valid. Because we are going to be passing each of these vectors and performing the same exact check on each of them, I would also like to create a helper function that just says, you know, is it valid? Is this a valid group? Valid group. And this is going to be taking a vector. So the first thing that we're going to want to do is we're going to want to solve for this lowest level case, which we are then going to use in all of these checks that are one level higher. So let's go and have our comment block to check us while we're doing the development of valid group. And what do we want to do here? We want to, as described on the Blackboard, we want to take account of the past vector minus any spaces, and we want to get the count of that same thing, a set of the same thing. So let's go ahead and just create 4, 5, 6. Sure. We're just going to say yeah, okay. So into set works, and if we have that, then you can see that the 3 is there. And then we can do a count of that is 6. All right. Let's go ahead and have that separately. Okay. And we will also want to be able to take out a value. And we did this recently with filter, partial, and not equal to, we can do it in this case with 5. And here, yeah, and so now we get rid of the 5. And we can, of course, go ahead and throw that into a set as well. Right. But I was looking at this earlier, and there's a way to write this a little bit more cleanly than using filter and not equals. You can instead use remove and equals. So partial equals 5, and then our there. And so that also does a good job of removing the values that are equal to 5 in this case, but it's much more readable. So that's actually the first thing that we want to do, is we're going to want to create that. So let's create a let binding, and we're going to say the v that only contains nums, and that's going to be a remove partial equal to, and in this case, our spaces, and it's taking our v. Good. And now that we have our vnums, we want to do a check to see equal the count of vnums is equal to a count. And instead of using an into set, we can do something called distinct and the same thing. Cool. So let's go ahead and throw that into our REPL, and we're going to move on. Well, let's see if this works. Valid group. Boom. And the valid group that we're going to have is, let's go ahead and take it from here. Boop. And we can go ahead and do this twice. And this one is going to have 5 in there. And so here, valid group is true, and this one, valid group is false. Nice. So I am pretty confident that valid group here is working as expected. Let's go now take advantage of valid group and use it inside of valid rows. And so what are we doing in valid rows? In valid rows, we want to check to see that every row in the board is valid. And this is something that looks very elegant and nice in Clojure. There is, in fact, a function called every. And so we could do we would say every valid group in, and we can use our valid board here. Yeah. And we can then go ahead and check that also against our invalid rows. False. So that is already going to be our answer. Super simple. Valid group, and then our board. Is every group valid? Yeah, that's our rows. All done. Now let's move over to the columns. And now the columns is going to be a little bit trickier because before calling every valid group, we need to rotate the board. And so the question is, how do you rotate the board? But we do know that we are going to do the same exact thing. But instead of just having board, we're going to have our rotated board. And here we're going to have some kind of let binding and somehow flip our board. And the question is, how do we flip our board? Well, I know that we're going to need to use map in this case, because if you look at map, what it does is it returns a lazy sequence consisting of the result of applying f to the set of first items of each collection, followed by applying f to the set of second items in each collection until any one of the collections is exhausted. So in our data structure, we have a vector of vectors representing rows. Map is going to check in each of those rows the first element. Well, the first element of each of those rows is our column. So we're going to use map somehow to pull out the columns from our data structure. And how could that look? Let's see, 1, 2, 3. Yeah, so if we have a map with partial plus 1 on 1, 2, 3, we've got 2, 3, 4. And if we've got another vector in there, it's 6, 8, 10. So what we're doing here is we say partial plus 1. And so we're going to do 4 plus 1 plus 1. That's 6. 5 plus 2 plus 1 is 8. 6 plus 3 plus 1 is 10. But we don't want to be adding 1 to this, rather we want to be throwing this into a vector. And so here we've got 1, 4, 2, 5, 3, 6, and this is the behavior that we're wanting to see. We throw into a vector the first element of each collection, then we throw into a vector the second element of each collection, then we throw into a vector the third element of each collection. So this is now our columns. Let's go ahead and check this out. Yeah, so 1, 4, 7, 2, 5, 8, 3, 6, 9. That is what we want to have. However, this is not the data structure that we have. We are working with a vector of vectors, and when we run map vector on this, we do not see the result that we would wish. And so the question is, how do we pull these vectors, these subvectors, from this outer vector? And the answer to that is apply. And what does apply do? Apply applies function f, so it's going to be applying map to the argument list formed by prepending intervening arguments to args. And if you look at the description for apply, this is in fact one of the use cases that is provided. So here, apply map vector, you've got this outer vector here, and it's going to result in AC, BD, AC, BD. Yeah. And it says that apply, what it does is it makes the equivalent code of map vector of A, B, C, D. Exactly what we were trying to get. And so the description says it might help to think of map and vector as slipping inside the argument. So apply helps you slip inside the argument list to give map vector A, B, C, D, which then becomes the executable form. And that is exactly what we want to do. So we have apply map vector of this, and shabam, we've got our columns. So our rotated board in this case is going to be the applied map vector of our board. So we can check that this is true by first checking against our valid board, which is true, and finally against our invalid board columns. Ooh, which is execution error. Oh, because we're not valid board, it's valid calls. And that is false. So here we are true, and here we are false. Good. So I think our columns is done. Let's move on to our blocks. And I think here we're going to be doing a similar call. We're going to say every valid group. And this time, instead of a rotated board, we're going to be passing in our blocks. But now the question is, you know, how do we get our blocks? And that's the million-dollar question. Let's go into a rich comment and figure that one out. Well, I think we're going to be wanting to use range here. Similar to Python, range is going to have a start, end non-inclusive, and a step, which we can use to get our starting positions for each of our blocks. So if you get 0, 9, 3, starting at 0, going to 9 non-inclusive in steps of 3, you've got 0, 3, and 6. And we can use that to get the 0th position here, the 3rd position here, and the 6th position here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And we can then go ahead and get the columns as well. So we can get the 0th column, the 3rd column, and the 6th column. And so you've got our starting positions for each block using range. And then once we have our first starting position, we then want another counter, which is going to say, starting from this starting position, go one, get the current, get the next, and get the one following that. and then move on to the next iteration. So you're going to have a range of 0, 9, 3, and then you're going to have just a range of 3, like so, to build up our individual blocks. And these are going to want to go into for loops. Do you call them for loops in Clojure? You're going to have to tell me down in the comments. So we would have I, and this is going to be a range of 3, a j, range of 3, and let's go ahead and print our I and j. And what do we get here? We've got 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, and these values can then go and get popped on top of a starting position here to get our blocks. So we would want to take this, and we would want to throw this guy also then into a for loop, and we would have our starting row range 0, 9, 3, and our column start column. And this is also going to be a range 0, 9, 3, and we're going to do plus start row and I, and plus start column and j. And let's see how that looks. Considerably larger, but there we go. 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Perfect. And then we start with 0, 3. And so what we have done here is we've grabbed first this block here, followed by this block here. And that, I guess that's our answer actually. So let's just let's yoink this guy and throw it on in there. I think we can go ahead and get rid of that. Okay, but in this case, we don't want to be using print line. We want to be getting values from our board. So how are we going to do that? Well, we're going to use get in, and let's check that out here. If we get the 0th element of get in, there's 1, 2, 3. And so if our board is a nested vector, then we need to be doing something like that. Ah, that's going to be 0, 2. Right. Okay. All right, good. So this is our board, and our results are going to need to look like this. This here is going to be our row. This here is going to be our column. And so we can go ahead and yoink the logic from our print line. Actually, we can just do, we would have here plus start row I plus start col j, and this guy here is going to be our board. Yeah. Good. So we can go ahead and replace this guy here with get in valid within our board. And we need to wrap this guy in a vector. And that should be our answer. All right, so let's check this guy out. We've got valid blocks. And we will be taking in our, let's go ahead and take in our valid board. And that's it. Yeah, true. And if we go and do valid blocks against our invalid board blocks, false. Great. So we have solved for our rows, we've solved for our columns, we've solved for our blocks, we've got our valid group. Let's pull this all together now and check to see if we have a valid Sudoku. So, in fact, there shouldn't have to be anything else that we need to do here. Valid in the valid board, invalid, invalid, invalid. Perfect. Perfect. Let's go test, check our test suite and see how that looks. So here is our test suite. You can see we've got a valid board, our invalid board block, invalid board row, and invalid column. Essentially, it's the same exact thing, just thrown into a def test instead of a comment block. And when we run it, we've got 4 passes, 0 failures, 0 errors as well. So it looks like we've got the solution. I hope that you like it. If you have any suggestions to make it cleaner or even nicer, please let me know. All right, and so here we go. We've got our top level check, valid Sudoku. Are our rows valid? Are our columns valid? Are our blocks valid? And then for each of our rows, columns, and blocks, our rows, we just grab the rows as they are and say, are you a valid group? For our valid columns, we rotate the board by using apply map vector, and then we use the same exact call, every valid group of the rotated board. For valid blocks, we have ourselves a nested for loop where we get our starting position for each individual block, and then at each individual block, we get the current position and then up to +2 in both the X and the Y direction, and get the value at that location. We pack that into a vector and we've got our blocks. Once we've got our blocks, we say, hey, for every block, are you a valid group? And if the answer is yes, our blocks are also good. Finally, we've got the valid group function, the thing that we've been calling this entire time. And what we do here is we take the current group, either row, column, or block. We remove all of the empty spaces signified by a period. And then we take a count of the result, how many elements are in the vector, and then how many distinct elements are in the vector. And if they are the same, then we have no duplicates, and we are indeed valid. That gets sent back up to the top. If there are no duplicates in either the rows, columns, or blocks, we pass out true. Otherwise, it is false, and we have an invalid Sudoku. So there you go. There's a solution, and I hope that you liked it, and I'll see you next time. Bye.